Hey kids, welcome to your companion video for your Unit 4 test review. Let's take a quick gander at that test review. And here it is here. You should have a copy of this in your possession. Just running through it, you need to be able to identify parts of the coordinate plane, graph and identify ordered pairs on the coordinate plane, draw a graph for a real-life situation. We'll do some examples with that one. You need to be able to determine if a relation is a function, and there's a variety of methods there that we talked about, including the vertical line test. Identify the domain and range. We'll do a couple of examples with that. Draw a mapping of a relation. Use it to determine if a relation is a function. Identify the independent and dependent variables in a function. Evaluate a function in f of x format for given values. Use function notation to represent a mathematical relationship, and they've got some problems for that. And using functional notation, we got that to represent a mathematical relationship, got that one. Determine if a set of ordered pairs shows a direct or inverse variation. We've got problems here, and we'll have a slide for that. And write the equation of a direct or inverse variation. So we'll work through the ones that we just had in this previous section, and then we'll do one graph. So my intention is that you would have actually done the entire study guide first, then watched the video. So please, if you haven't done that, cease now watching the video. Please turn it off, go sit down, finish the study guide. Okay, this is how you study. You practice doing math. You can't really study just by watching a video. That's not going to be the best method of delivery for everybody. So you've got to sit down and do the practice too. All right. Now, if you've done that, now you can go ahead with the video. All right, first section. So we're sketching a graph to represent each of these situations here. So let's start with the first one, which says hours of daylight each day over the course of 1 year. Well, if we're starting at January and we're going through December, remember that in January it's wintertime. The hours of daylight you have is on the downward slope. And so, well, would that be true? I guess at that point it would be on the upward slope. Is the shortest day of the year December 20th? I feel like that's true. Anyway, all right, so let's say it's on the upward slope. So the number of hours of daylight is going to maximize in June and come back down in December. And that's probably a little too extreme. It's probably not quite that steep. Maybe a little bit more like this. All right, instead, but you catch my drift. All right, so that's number 11. Number 12. Your distance from the ground as you ride a Ferris wheel. Oh, this is similar to the one we had that was the swing in the previous in a previous video. So this is time here. All right. Oh, and I should have labeled this over here, hours. All right, so time here and height, distance off the ground. And if you're on a Ferris wheel, your distance off the ground is going up, and then it's coming back down, and then it's going back up, and then it's coming back down. It's going back up, and then it's coming back down. All right, or I guess I should probably have stopped it there, so let's hold on, let's fix that. There we go. Good, 13. Your pulse rate as you watch a scary movie. Well, it's not going to go nuts, and it's not going to be at 0. So again, we'll have time and pulse rate. Okay, so the time is the time that's passing as you watch the movie. So your pulse rate is probably going up, going up, going up, and then maybe it'll spike, and then it'll come back down at the end of the movie. And be back to normal. And so that, I think, would give you the general gist of each one. And so that's the sort of thing you should be able to be prepared to do on your test that's coming up. Next. Use the vertical line test to determine if these are functions. And I also added in the directions on the study guide, also state the domain and range. And we talked about the notation for that. And look, we've got 3 of them that are like those ones that we wanted a little extra practice with in class as well. So let's start with this first one. Is this a function? No, it is not. It is indeed not a function. It fails the vertical line test. You have 2 values, or 2 points, I should say, with an x value of -1. So let's go ahead and state the domain and range anyway. Domain here is going to be -2, -1, 1, and 2, listing them in numerical order, no duplicates. The range is going to be -1, 1, and 2. Again, we're not listing any duplicates. All right, good. Next one, 13. Is it a function? No, it's not a function. And we know it's not a function because this one also fails the vertical line test. If you're not seeing it, there would be an example right there of a vertical line that passes through 2 of two ordered pairs at in one shot there. All right. But this time, domain and range. When we state the domain and range, we're going to have to do it in terms of something a little bit different. It's not discrete, okay? This kind of function, remember, is discrete. And no, it doesn't mean it's like it keeps its secrets. No, that's not what it means. It means it's individual points, discrete, separate points. These, the rest of these, all three of these here are instead the opposite, which is continuous. Continuous versus discrete. Anyway, the domain. Well, you've got 0 and up, 0 and up, because the x values are where x is greater than or equal to 0, nothing negative. Okay, there's no points that are negative. What about the range? And that's right, nothing is restricting the range, all real numbers. Good, how about the next one, number 14? Yes, that is a function. And the domain and the range. Again, domain and range in the format of an inequality or a phrase. The domain here, nothing is stopping that from continuing on to the right and left. So domain is going to be all the real numbers. But the range has a minimum value of 1. So y is greater than or equal to 1. All right, number 15. Is that a function? Yes, it is. It's a linear function. And as a result, the domain and the range both have the distinction of being all real numbers. There are no values on the x or the y-axis that will not eventually have a point on that line. Awesome, moving forward. Okay, given the function in function notation, evaluate the given function for this domain. So we didn't look at problems quite like this, but this is just a chance to practice a bunch of functional notation. If you're given the domain, basically what you're supposed to do here, so like number 11, is to actually go ahead and evaluate this function for all of these values, all of these numbers. Like so. So we're finding f of -4 and -2 and 0 and 1.5 and 4. So it's just plugging it in. So let me go ahead and give you some answers. We'll just write it out nice and quick. And there we have the first one, f of x. So f of -4 is 5, and so on down the line. So remember that all we're doing here is evaluating. All we're doing is plugging in the number in the parentheses, in for x, doing the math, getting the answers, and there you go. Let me go ahead and write out number 12 for you. And there's your answers for number 12. So plugging in the values for x in this one, the important thing to remember here is that when you square negative, you get a positive. So -4 squared and 4 squared both get the same result, and as a result of that, when you plug in the 4 or the -4 for x in this function, you do get both of them as 84. And I thought that was something important to point out. Okay, continuing. Okay, some function rules to write out. So, number 1, let's take a look at that. We have the total cost C for P pounds of copper if each pound costs 3.57. So C of P. The cost is a function of the number of pounds. And what do we do to the number of pounds to get the cost? We multiply it by 3.57. So 3.57 P equals C of P. 2. The height f in feet of an object when you know the height h in inches. This is the opposite of one we had on an exit quiz, so hopefully you've already taken that. The height f in feet, so the height in feet is a function of the height in inches. So what do you do with the height in inches to go to feet? So you would take h and you would divide it by 12. You have the height in inches. Your answer is going to be a smaller number if you're taking that height in inches and changing it to feet, because you need fewer of them to cover the same distance. 3. The amount y of your friend's allowance if the amount she receives is 2 more than the amount you receive. So we could write that y of x. That sounds a little awkward, so I'm not entirely comfortable writing it that way, but I would probably end up changing it to f of x. So I'm wondering if maybe in this circumstance the textbook didn't really intend for us to use function notation all of the time. And really, what is your friend doing comparing the allowance that she gets to what you get? She can go fly a kite. All right. 4. The volume V of a cube-shaped box whose edge lengths are 1 inch greater than the diameter D of the ball that box will hold. This one is a little tougher. So the volume is a function of the diameter d of the largest ball that the box will hold. Okay, so the sides, the edges of the box, are each going to be 1 inch greater than the diameter of the ball. So if I'm thinking, let's draw this out. So if I've got this 3D figure here, and the ball is inside, okay, please forgive my lack of artistic ability. The ball is inside, and the ball has diameter d. Each edge is going to be 1 inch greater than d. Well, to find the volume of a cube, you take that edge and you multiply it by itself 3 times. And that, my friends, is the function rule for that one. That one was tough. All right, direct inverse or neither. So remember we did some of this in a previous video, so one more time, let's give this a shot. We're looking at starting off with the ratio. If you check the ratio of y to x and it's constant, it's direct. So again, y equals kx, or k equals y over x. For inverse, it's y equals k over x. And again, if you have it solved for k, if you have it written in that format, k is equal to xy. So if the ratio of y to x is constant, it's direct. If the product of x and y is constant, it's inverse. So let's get started with them. All right, so for this first one, I'm going to start off by finding the quotient of 20 and 1.5, but I can very quickly see that is not going to be the same as the quotient of 12 and 2.5. So this is not going to be a circumstance where we have direct. What about inverse? Find the product of each ordered pair. 1.5 times 20 is 30. And the same thing with 2.5 and 12. That's also 30. 4 and 7.5, also 30. 5 and 6, also 30. So the product of the two of them is consistent, and it is the same. That means this is an inverse variation. Now the second section, the next section here says, on the study guide says that I want you to find the equation for this. Once you know what it is, all right, so in this case, inverse, I'm going to write it in this little space right here, you also have the constant of variation. And in this case, your constant of variation is 30. So this is y equals 30 over x. All right, good. Next one. All right, so let's start with ratio. 217 over 31 is 7. 140 over 20 is 7. 119 over 17, 7. 84 over 12, 7. This one is direct. And because I know that k is the number I kept getting there, it's 7, the equation is y equals 7x. Next, 36 over 3, that's 12. 105 over 7 is 15. Not the same, not direct. 36 times 3 comes out to be 90 and 18, 90, 108. But 7 times 105 is definitely not 108. All right, so that means that the ratio wasn't constant. The product was not constant because that was not 108. This one was not 108. That this one is a neither. Neither. All right, last one. Again, we have ratio 16 to 4. That's 4. All right, 12.8 to 5, not equal to 4. Okay, so it's not direct. What about 4 times 16? That's 64. And 5 times 12.8, that's 64. And 1.6 times 60, that's 64. All right, we've got an inverse situation on our hands. So this one's inverse, and there's your equation. Y equals 64 over x. All right, so the last thing we need to do is graph our one direct variation, which was y equals 7x. So let me start by putting down an x and a y-axis on my graph. And there you go. I made them a little dark, but that's okay. What ordered pair is always on a direct variation? That's right, 0, 0. So go ahead and plot yourself some 0, 0. And all you need is 1 or 2 other points. Let's find 2 other points. Let's put in 1 for x. What comes out for y? 7. How about negative 1 for x? What comes out for y? Negative 7. So 1, 7 would be right here. 1, negative 7 would be right here. And the line that you would connect between them, ooh, definitely not perfect. Pretend it's straight. Very hard to draw a straight line with a stylus on the iPad. I know, excuses, excuses. But that's graphing the direct variation. And that leads us a little bit over 15 minutes, so I'd like to call it quits. We'll be going over this, we'll be going over any questions you have, practicing with word problems, and otherwise making sure we know what we're doing with this unit in class next time. And I will see you then.